Hi everyone, today we are going to see how to install Google Cloud SQL Proxy in Kubernetes engine. We need to some prerequisite. You have to create a Google Cloud Platform account with billing enabled, and you have to install the Google Cloud SDK, and then the Kubernetes component should be installed in your machine. So these are the prerequisites. So look at here, I have a account and created the project in Google Cloud Console project. If you don't have the project, create a new project, and then billing should be enabled. So look at here, for my account billing is enabled. Okay, so the next one, you have to install the Google Cloud SDK in your machine. I already installed that G Cloud. So the version is 1.186.0.0, and also I configured my G Cloud account and then the project. Okay, so the next one, you should have to install the Kubernetes component. So look at here, the component is installed in my G Cloud. So if you don't have the component, so please install it. And then these are the installation steps. First step, to create a Kubernetes cluster and then create a Cloud SQL instance, second generation MySQL, and then enable the Google Cloud SQL and API services, and then the service account, proxy user, create a secrets, and create and run the MySQL deployment YAML file, and then create and run the service YAML for Cloud SQL Proxy, and then create a Toolbox Docker image. It is a utility to connect the SQL, and then push the Toolbox Docker image into the container registry so that you can create a deployment YAML to create a toolbox pod, and then connect the Cloud SQL database from the toolbox by using the service name. So these are the steps we need to focus. So first step, create a Kubernetes cluster. The cluster version is 1.7.11 GKE1, and then the machine type is 1V CPU, node image is container optimized OS, and then the node size is 3. So go to the Google Cloud Console, select the Kubernetes engine menu, and then it will redirect into the Kubernetes cluster page. If you don't have the cluster, please create a Kubernetes cluster. Okay, so here I provided the name Cloud R&D. So this is my cluster name, and then the description, it is an optional, so you can provide the description for your cluster, and then the zone, and then the cluster version is 1.7.11, and then machine type is 1V CPU, and then the container optimized OS is the node image, and then the size. Okay, so rest of the fields keep the default value, and then click create button. So it will create a new cluster. It will take few minutes to create a cluster in your account. After create the cluster, you should have to set the default Kubernetes cluster in your G Cloud configuration. So this is the command to set the default cluster, G Cloud config set container or cluster, and then the cluster name. So if you do the G Cloud config list, it will show you the container name, the cluster name, the default cluster name, and then you have to connect the cluster. So if you click the connect button, it will show you the command to connect your Kubernetes cluster by using the G Cloud command. So after you execute the command, so the next step, you have to create a Cloud SQL instance. The MySQL version is 5.6 or 5.7, and then the instance type is second generation. Now go to the SQL in the Google Cloud Console. Okay, so here the SQL menu is there. Click the Cloud SQL, and then create a Cloud SQL instance. Choose the database engine, MySQL version 5.6 or 5.7, and then choose the second generation instance, and then provide the instance ID. The instance ID cannot be changed later, so use the lowercase letters, numbers, and hyphens, and it should start with a letter. And then the password, here I am setting the default password like root, and then give the rest of the fields as a default value. Click create. So the instance will take few minutes to create in your account. After create the instance, you will get the green tick here, and then this is the instance connection name. And then if you click the instance, so you can view the overview of your instance details, how to connect this instance, and then how to create a backup, and then the configuration of your instance, so your operations and logs. So these are the overview you can see. And then you have to enable the Google Cloud SQL and API services, Google Cloud SQL and then API, and then the Google Cloud Data Store API. Data Store API is an optional. And then go to the API and services in the Google Cloud Console. So click the dashboard link. It will redirect into the API and services dashboard page. And then click enable and API services. In the search text box, type SQL. So look at here the Google Cloud SQL. In my account it is already enabled. So if you don't have enable, so please enable it. And then this is the Google Cloud SQL API, and then this is the optional Google Cloud Data Store API. This is for NoSQL data document database, so please enable it. It is an optional field, you don't want to enable it for this demo. Okay, so create a service account. So provide a valid service account name and then the service account ID, and then furnish a new private JSON type as a account key. So you have to create a service account to access the Cloud SQL services by using the Cloud SQL Proxy. Okay, so go to the IAM and admin, and then click the service account. Already I have some default service account. So here now I am going to create a new service account. The service account name I am giving here Cloud R&D service, and then the role. This is the important, you have to choose the role. So here for this service I am giving the Cloud SQL client role and then the project editor role. Okay, so these are the two roles we need to provide for this service, and then furnish a new private key as a JSON type. After click the create button, so the JSON will download into your machine. So service account and key is created successfully. And then go to the downloaded JSON key file and then open it. It will have the JSON type, you have the private key and then the client email, client ID, everything you have. So this is the detail, you have to keep it in your machine. And then create a proxy user. Use the gcloud command below to create the user account named proxy user that the proxy will use to access your Cloud SQL instance, filling in the instance name and the password. So below is the command gcloud SQL users to create a proxy user, and then the host name is Cloud SQL Proxy, and then the instance name and then password you need to provide to create a proxy user to access the Cloud SQL Proxy from your Kubernetes engine. Go to the SQL and then you can see the instance name here. So this is the instance ID, this is your instance name. Okay, so this instance ID you need to provide while creating a proxy user in the command. Okay, so this is the command to create a proxy user. Create proxy user and then the host and then the instance name Cloud R&D DB, and then the password is root. So the password is, you are setting the password for the proxy user. So it will create a Cloud SQL user. After created the user, you can see the list of users in the console. Okay, so look at here in the after you click the instance and then in the users tab you can see the proxy user here. So previously we have the default user root, now we created the proxy user. Okay, so the next step, you have to create a secrets. You need to create 2 secrets to enable your Kubernetes engine application to access the data in your Cloud SQL instance. The Cloud SQL instance details secret contains a service account. The Cloud SQL DB credentials secret provides a proxy user account and then the password. So you have to create 2 secrets. The first secret is create the secret containing the service account which enables the authentication to Cloud SQL. kubectl create secret generic and then the Cloud SQL instance details, and then the credentials JSON, the path you have to provide, and then create secret needed for the database access using the name and password for the proxy user you created earlier. So this is the command to create secret generic Cloud SQL DB credentials and then the username and then the password. So these are the two commands you have to use to create a secrets in your gcloud account in your Kubernetes cluster. Okay, so look at here, the kubectl create secret. The first step, I'm creating a Cloud SQL instance detail secret. So in the credentials JSON, you have to provide the service JSON path. So it will create the secret Cloud SQL instance details. Okay, so next one we have to create the Cloud SQL DB credentials. So look at here, the Cloud SQL instance credentials is created. Next one is the Cloud SQL DB credentials, and then you need to provide the username and password for the proxy user, and then the Cloud SQL DB credentials also created. If you want to access the database from your in your one of the pod, you can use the DB credentials, and then create and run the MySQL deployment YAML file. The name is Cloud SQL Proxy. The image is already available in the Cloud SQL Docker, the GCR. The volume name is Cloud SQL Instance Details, and then the volume secret name is Cloud SQL Instance Credentials. Then the mount path, I am going to provide the secrets and the Cloud SQL. So now I am going to create a YAML file. So here I am using the Eclipse to create a YAML file. I already installed the YAML editor. So if you have any YAML editor, you can use it. Okay, so in the MySQL deployment YAML file, you need to provide the API version, extensions v1 beta 1, and then the kind is deployment. The metadata name is the Cloud SQL Proxy. Okay, the next one is the replica. I am giving only one. So if you want to use more than one replica, you can provide here. And then the template metadata label app name, I'm providing Cloud SQL Proxy, and then the unit name is the My Cloud SQL. This unit name is used to connect the service, and then the specs we need to provide for the containers. Okay, so it should be the specs template, and then the spec container name, and then the image you need to provide, and then the name I'm providing Cloud SQL Proxy, and then image is available in the Cloud SQL Docker GCR repository. Okay, and then the command, this is the command to execute the to connect the SQL. So here you need to provide the instance connection name. So this instance connection name you can see in the instance of your gcloud console. So look at here, this is the instance connection name. Just copy this instance connection name and provide it in the YAML file, MySQL deployment YAML file. Okay, so the instances name is Cloud Techie, and then the location zone, and then the instance name, and then the volume mount, I'm providing the Cloud SQL instance credentials, and then the mount path secrets Cloud SQL, and then the read only I'm providing as a true, and then this is the volume for the Cloud SQL instance credentials, and then the secret name is the Cloud SQL instance credentials. Okay, so this is a YAML file. You have to use the tab as correctly, otherwise it will show you the error. Okay, so here I am providing the volume name as Cloud SQL, and then the empty directory. Here I am just giving the empty value. Okay, so this is the deployment YAML file to create a Cloud SQL proxy into your Kubernetes engine. Okay, the MySQL deployment YAML file is created. Now I am going to execute this deployment YAML file into the Kubernetes cluster. Okay, so look at here. So MySQL deployment YAML file is available here under this directory. So if you want to execute this, use the command kubectl create -f and then the deployment file. So deployment Cloud SQL proxy is created. You can see the pods by you executing the command kubectl get pods. So it will show you the list of pods running in your Kubernetes cluster. So look at here, the Cloud SQL Proxy, only one pod is running, and then the status is running status. The next step, we are going to create a service. Create and run the service YAML for Cloud SQL Proxy. The kind is service, and then the service name I am going to provide CloudDB, and then the port is the default port 3306. Okay. So now I am going to create a MySQL service file. So this service file is used to connect your Cloud SQL by using the service name from any one another pod or something. Okay. So within the cluster. So here the API version is the v1, and then the kind is service. Metadata name I am providing here the CloudDB. Okay, so the next is the spec is port number is 3306, and then the name is the Cloud SQL. Okay, so and then the selector unit is my Cloud SQL. So in the deployment file we use the selector name as the my Cloud SQL. That's the same selector unit name you have to provide in the service YAML file. So this is the MySQL service YAML file we created. Okay, so this YAML file is available under the service directory in my machine. So look at here, I created the file MySQL service YAML. Now I am going to run this YAML, the service YAML. The command is kubectl create -f mysql _service.yaml. So it will create a new service to access the Cloud SQL Proxy pod by using this service. So if you want to connect the Cloud SQL Proxy, you have to use this service name as a host CloudDB. So look at here, the kubectl get services. It will show you the list of services running into your Kubernetes cluster. So this is the list of pods, and then the list of services is running now. So far we created the Cloud SQL Proxy, and then we created the service for that Cloud SQL Proxy. Now I am going to create a Toolbox Docker image. This is a simple Docker image which contains the Ubuntu OS and then the default MySQL client and the JRE telnet. So these are the commands I executing into the Docker image, and then the repository name I am providing a gcr-io, the project ID, and then the name, the version is 1.0. It's nothing but it's a simple Docker file. I mean, I'm going to create a simple Docker image which contains, we can execute the default Java versions and then the MySQL client and then the telnet and then IP utilities, everything from the Ubuntu OS. Okay, so this is the Docker file I created from the Ubuntu OS. I'm just executing the apt-get update, and then I'm installing the MySQL client, default JRE, NetTools, IP utilities, Netcat, Redis tools, and then everything. So this is a simple Docker file. So I created this Docker file under the service directory. Okay, so look at here, the Docker file is created. Now I am going to create a Docker image with the repository name the GCR. Okay, so Docker is running in my machine already. So there is no Docker images. So here I am using the Docker version is 17.12. Okay, so this is the Docker version I am using. Now I am going to create a Docker image by using that Docker file. Docker build -tag equal to, here I am providing the repository name. The repository name should be in this format only, gcr-io, and then the GCP project name. The project name is Cloud Techie, and then the name of the image Toolbox : and then the tag name is 1.0. Okay, the next step, the next argument, you need to provide the Docker file directory. So Docker file directory is available in the service directory in my machine. Okay, so you can create the Docker file in any one of the directory in your machine. So it will create a Docker image. Okay, so look at here, it will take few minutes to create a Docker image. So because it needs to install the Ubuntu OS and then all the default MySQL client and the JRE everything. So Docker image is successfully tagged. So look at here, If you execute the command docker images, the repository gcr-io cloud techie toolbox, and then the tag is 1.0, the docker image is created. Now push the docker toolbox docker image into the container registry, and then this is the command to push gcloud docker -- push, and then the docker image. This is the command to push the docker image into your container registry. So gcloud docker -- push, and then the repository name colon, and then the tag name. The tag name is 1.0. So if you execute this command, it will push your docker image into the gcloud container registry. After push the docker image successfully, go to the Google Cloud Console and then search the container registry. So if you go to the container registry menu, you can see the Toolbox docker image here. So look at here, the gcr io, the cloud techie, and then the docker image, the toolbox. So docker image is successfully uploaded into the container registry. Okay, now create a toolbox deployment YAML file. The name is the toolbox, and then the image is gcr-io, and then the project name, and then the docker image name. Now I'm going to create a toolbox deployment YAML file. So it will create a pod into your Kubernetes cluster to access the Cloud SQL from this pod. Okay, so here I am creating a deployment. The metadata name is toolbox, and the label name app is the toolbox. It's a simple deployment file. It will run the pod. Okay, the specs template name, metadata, labels, and the app I am providing is a toolbox, and then the spec container name is the toolbox, and then the image is the GCR. The image is already available in the GCR container registry. Okay, so look at here, this is the image, gcr-io cloud techie, the toolbox. So the toolbox deployment YAML file is created. Now I am going to execute, create this deployment in the Kubernetes cluster. So look at here, the toolbox YAML available under the service directory in my machine. So kubectl create -f, and then the toolbox.yaml. It will create a new deployment. Deployment toolbox is created. It will take a few minutes to run the pod. Okay, if you execute the command kubectl get pods, it will show you the status of your pods. So the toolbox container is creating now. So again you execute, the status is running now. So the toolbox is running now. Now I am going to connect this toolbox by using the command kubectl exe. So before that, already the service is running now, the kubectl get services. So the cloud db services, this is the service name I'm going to use to connect the cloud SQL database. So execute this command kubectl exe-et, the toolbox pod name, and then the bash. So it will go to your inside the toolbox. So inside the toolbox, I already the MySQL client is installed in the Docker image. So I am executing the MySQL command to connect the Cloud SQL Proxy. The service name is CloudDB. The service is already running in the Kubernetes cluster. Look at here, the CloudDB. By using this service name, I am going to connect this. So already the user and password I provided in the command. So the Cloud SQL Proxy, the server version 5.7.14, the Google Cloud. So the Cloud SQL is connected successfully by using the MySQL client and then the service name. So if you execute the command show databases, there is no databases now. These three databases are the default database. Now I am going to create a new database. Create database testdb. So database is created successfully. Okay, so then if you look at here, connect Cloud SQL database from Toolbox by using the service name MySQL-user, the username -p, password -a, and then the host name. So this is the command I executed. Okay, so I can able to connect the Cloud SQL proxy from the Toolbox Docker image by using the service name CloudDB, and then I created the database testdb. Okay, so go to the SQL in the Google Cloud Platform console. So go to the instance details and then click the databases tab. You can see the list of databases available in the Cloud SQL. So look at here, the testdb is displaying here. So we created the testdb databases by using the Cloud SQL proxy with the service name. Now I am going to create a table test. So create table test id int primary key, and then the name is the varchar 45, the length of the name. Okay, just simply I am creating a table. Oops, no database selected. Now I'm going to use this database testdb, and then now I'm created the table test, and then if you execute the command show tables, it will show you the list of tables available in this database. So you can exit the MySQL prompt and then the container. If you execute the command kubectl get pods, it will show you the list of pods running in your machine. If you execute the command kubectl get services, it will show you the list of services. I can able to connect the Cloud SQL proxy from the by using the service name in the container. Okay, so look at here, the service name is CloudDB and then pod is running. So thank you for watching this video. Please subscribe my YouTube channel to get more videos. Then like my videos and share my videos. Thank you.